In this tutorial, we're going to look at the visual properties of objects inside of Unity. We're going to look at polygon counts by using the rendering statistics window. We're also going to look at comparisons of high polygon versions and low polygon versions of objects. We're going to look at how to use level of detail groups or LOD groups to basically fix the issue of switching between high polygon and low polygon objects. We're also going to look at some material properties and some lighting properties. So first, I'm going to go ahead and start with the same Snaps office environment that I've used in previous tutorials. I already have an XR rig set up inside of this environment. I've increased the tracking radius to 2000 so that I can simulate the user freely walking about without having to worry about any type of virtual travel. So let's go ahead and take a look at this environment from the first person perspective. So down here in the game view, you can see what the first person's perspective looks like. I can use the shortcut key to basically look down and look around the environment. Right now you see the two rays that are included by default in the XR rig for the left and the right hand controllers. Using the rig, I can basically just move these objects around to get them out of the way if I don't want to see them. But this gives you an idea of basically what the environment looks like. Now, the question is, though, how many polygons are we looking at? So if we click on the stats window here in the game view, this will bring up the rendering statistics. So currently, in this current view, we have about 120,000 triangles or 180,000 vertices. If you notice, as I move further back into the room, which means more of the objects within the room are within the field of view, we're talking around 200 triangles or 300,000 vertices. So the numbers get much higher. If I look up a little bit, that number will increase even more. So this is just due to the fact that there's literally more triangles and vertices within my field of view. And as I walk forward, you'll see those numbers decrease all the way until you have very few triangles, sub 100,000 triangles, and just very few. Okay. So this demonstrates the rendering statistics window. Now, let's go back to the startup. If you notice down here, this looks like a standard office desk. However, it looks okay for the most part, except for this keyboard. This keyboard is obviously very low poly. It's literally just an outline view, and it looks as if it has a single button. There's no representation at all of the 100 and some keys on the keyboard. So in general, this is super low poly. So what if I want to change this? So on the asset store, I've already located a free keyboard asset, the keyboard with adjustable colors. I've already imported it into my folder system. I have a nice little prefab here and a nice little model. So we can take a look at the model here. You can see it up there. So what I'm going to do is I'm going to go into my virtual environment representation. I'm going to find the representation of the keyboards, which are in section 2. So here's one of the representations. And if you'll notice, all of the keyboards within the room reference the same prefab. So if I change this prefab, I will actually change all of the keyboards in the room. So to do that, I'm simply going to right click on this keyboard prefab, and I'm going to open the prefab asset. And here we can see the keyboard that has been basically populated throughout the virtual environment. And what I want to do is I essentially want, instead of seeing it, I want to see this higher polygon version of a keyboard, which I'm just going to add the prefab as a child of this one. We can't currently see it, and that's because this mesh render is in the way. So there we go. We actually can see the high poly keyboard there. It's actually rotated incorrectly, so let's fix its rotation here quickly. And now if we take a look, it's actually rotated correctly. A few comments here. So first off, I had just disabled the mesh renderer, but I'm no longer going to use this top node as a mesh. So I'm going to remove the renderer and I'm going to remove the mesh itself. The current box collider that's on the parent object is actually not quite suitable. So the reason for that, I'm actually going to just copy these values and I'm going to paste these values here. And that ensures that basically I have the exact same box as before. And now because I have a box collider for the parent, I actually don't need this box collider on the child prefab. And if you're wondering about this outside box collider, that's actually just the nav mesh obstacle. I'm going to leave that on for now. You could actually rechange it or resize it if you want to. I'm not going to worry about that right now. And if we finish up with our prefab and we go back to our scene, we will see that every single keyboard has now been replaced with this high poly version, which looks much better. However, there's a problem with this. So if we press play and we take a look around the environment, you'll now see instead of us being between 100 and 200,000 triangles, we're now around 596,000 triangles or 488 vertices. If I step back in the room, that number grows past 1 million, which is an unacceptable number of polygons. And this is all simply due to me replacing that simple keyboard with this much more complex keyboard. Now, obviously I could revert back to the simple keyboard, but what I would like to happen is when I'm near one of these keyboards, I can see the high fidelity version, and when I'm not near one, because I can't really make out the high fidelity definition anyway, that I would get the low poly representation. And we can achieve this by using what's called a level of detail group, or LOD group. So let's go back to our prefab. I can choose any of the keyboards to open up the prefab. And we're going to create one of these groups. So the first thing, I'm going to create an empty child object, and we will call this the low poly keyboard. And I'm going to go into the Snaps Office environment, and I'm going to find the mesh for my keyboard, and I'm going to add it to this new empty game object that I created. And you can see kind of the outline of the keyboard right now. The original keyboard was much larger than this new keyboard. Not much larger, but a little larger. So I'm going to simply go ahead and scale this guy down uniformly by using the rotate widget in the center gray box. And we'll say that approximately matches. Now, one thing that you may have noticed here is on the new low poly keyboard, it seems to be missing mesh where the keys themselves are. That is due to the fact that this particular mesh asset assumes that you have two materials. So if I increase the material size here to 2, even though I have no materials, which is indicated by the fact with this pink coloring, at least I now have a mesh representation. Now, how do I fill in these materials? This is quite simple. I already have materials here provided by the asset package. I could create my own materials by simply right-clicking, click create, and then you click materials that way. For the time being, I'm just going to use the materials that are already there. I'll use the dark gray material for the first element, which is the outer border of the keyboard. And let's use the regular gray material for the inside, the way that the keyboard originally was. If you want to see the details of these materials, you can find them down below by simply expanding these material inspectors. You'll notice that both of these are standard shader materials. They're both opaque. They don't even have textures assigned to them. They are simply color-based. You can actually modify these colors. Though in this particular example, I have to be careful because these materials that were provided by the asset package are used throughout the environment. So for example, if I were to change my dark gray to another color, it changes a lot of things in the environment. So I'll change it back to a dark gray there. So right now what we have And let's actually turn this mesh collider off. We don't need that. So what we have right now is we have two different objects as children of this primary object. However, we don't want to see both objects. In fact, the high fidelity object is currently being included by the low fidelity object. So how do we fix this? So the way that we do this is we add an LOD group to our parent object. And when you add this, you'll see that you have 3 levels of details that you can work with. LOD 0 is your highest quality. This is your high polygon model. So I'm going to go ahead and simply drag my keyboard, the high poly one, into that area. And you'll notice that its render has been added here down below. For the level of detail 1, I'm going to use the low poly for now. And for the level of detail 2, I'll also use the low poly since it's the furthest one away. And let's take a look at this to see, actually let's go back to the scene. So right now you'll see that this is the lowest level. This particular view is actually based off of my scene camera. So as I slowly move away from it, you can see the change. So actually from this view right here, I can already tell that it's basically switching to the low poly version a little too soon, more soon than I'm comfortable with. So I'm going to go back into the prefab and I'm going to assign my high poly keyboard to the LOD1, and I'm going to, actually I'm not quite sure which one it is. Yep, it would be that one. So I have high poly for LOD0, I have high poly for LOD1, and I have the low poly for LOD2. So we'll go back to the scene. So this is LOD0, LOD1, and then LOD2, it kind of flips off, but it's far enough away that it doesn't really matter. So if we press play on this, we'll see that my polygon counts were decent. We're back more closer to what we originally were. From this point right now, you can see that we have a high fidelity model right here. We have these other keyboards are represented by the lower fidelity models. If I move closer to them, they will switch to the higher fidelity models. It is a little bit jarring in this particular example. Ideally, I would have a low poly version of the keyboard that's not quite as low poly as what we're working with, but that's perfectly okay for this demonstration. Now, a few other things to account for. I want to demonstrate in this tutorial, you've already seen the material properties, but what about the lighting properties? So just for example, right now in this scene view, you can see that this chair is casting a shadow. And that's because if you look at its mesh render under lighting, cast shadows is on. It's also the case too that like for example, this object, not only is it casting a shadow, but it's also receiving a shadow. So what if I didn't want that to happen? That's not a very realistic thing, but let's assume that I didn't want that to happen. I could open the prefab. I could simply say, don't receive shadows and don't cast shadows. And then if I go back to the scene, you'll now see that this object is neither casting shadow, nor is it receiving shadows. Obviously, this isn't very high fidelity, but if for whatever reason you were looking for a certain aesthetic appearance, maybe an environment with very few shadows, you can play around with these lightings effects. You also have probes and other advanced settings. Feel free to go through the Unity documentation to learn more about those.